Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Oltu is a powerful open-source library designed to help developers implement secure authentication using the OAuth protocol. It supports both OAuth 1A and OAuth 2 standards, making it versatile for various types of applications. Whether you're building a web service or a mobile app, Oltu provides the tools needed to manage user permissions and secure access to resources. This makes it especially valuable in today's security-conscious development landscape. OAuth is an open standard for access delegation, commonly used as a way for users to grant websites or applications access to their information on other services without giving them the passwords. For example, when you log into a website using your Google account, that's OAuth in action. There are two main versions, OAuth 1A and OAuth 2, with the latter being more widely adopted due to its improved simplicity and flexibility. Implementing OAuth from scratch can be complex and error-prone. Apache Oltu simplifies this process by providing pre-built components for handling authentication flows, token generation, and request validation. As a Java-native library, it integrates seamlessly with existing Java-based systems. Its modular architecture also allows developers to customize only the parts they need, reducing overhead and improving maintainability. Apache Oltu is composed of several core modules that handle different aspects of the OAuth flow. These include the OAuth client module for initiating authentication requests, the server module for validating tokens and managing sessions, token handling utilities for generating and verifying access tokens, and request response processors for parsing and formatting OAuth messages. Each component plays a crucial role in ensuring secure communication between clients and servers. In OAuth 2, there are 4 key roles involved in the authorization process. The resource owner is the user who owns the data, such as a person logging into a service. The client application is the software requesting access to the user's data. The authorization server is responsible for authenticating the user and issuing access tokens. Finally, the resource server hosts the protected resources and validates the access tokens before granting access. OAuth 2 defines several grant types, each suited for different use cases. The authorization code grant is the most secure and is typically used for server-side applications. The implicit grant is used for browser-based apps where the client cannot securely store credentials. The resource owner password credentials grant allows users to provide their username and password directly, while the client credentials grant is used for machine-to-machine communication. Apache Oltu follows a modular architecture that separates concerns between client and server implementations. This design allows developers to use only the components they need, whether building a client application or an authorization server. The token management layer handles the creation, storage, and validation of access tokens, while protocol-specific handlers ensure compliance with OAuth standards. To get started with Apache Oltu, you'll first need to add the necessary dependencies to your project, typically through Maven or Gradle. Once installed, configure your OAuth settings such as redirect URIs, client IDs, and secret keys. Then initialize either the OAuth client or server depending on your use case. Finally, test the setup with sample requests to ensure everything is working correctly. Implementing an OAuth client involves creating an instance of the OAuth client class, building the authorization URL that the user will be redirected to, handling the callback after the user grants permission, and exchanging the authorization code for an access token. Once you have the token, you can use it to make authenticated requests to the protected resources on behalf of the user. Building an OAuth server requires setting up an authorization endpoint where users can grant permission, validating client credentials to ensure only trusted applications can request access, issuing access tokens upon successful authentication, and protecting resource endpoints so that only requests with valid tokens are allowed. This ensures secure access to sensitive data and services. Token management is a critical part of OAuth implementation. Apache Oltu provides utilities to generate both access and refresh tokens, store them securely using encryption or secure storage mechanisms, validate token expiration to prevent unauthorized access, and revoke tokens when a user logs out or revokes permissions. Proper token management helps maintain the security and integrity of your application. Security should always be a top priority when implementing OAuth. Always use HTTPS to encrypt communications between clients and servers. Validate tokens thoroughly before processing any requests to prevent unauthorized access. Limit the scope and lifetime of tokens to reduce the risk of misuse. And never store tokens in plain text. Always use secure storage methods such as encryption or secure cookies. The authorization code flow is the most commonly used OAuth 2 grant type for web applications. It starts with the user being redirected to the authorization server, where they log in and grant permission. The authorization server then returns an authorization code to the client, which exchanges it for an access token. This token is then used to access protected resources on behalf of the user. The implicit grant flow is designed for browser-based applications that cannot securely store client secrets. In this flow, the access token is returned directly to the client via the browser, without an intermediate authorization code. While simpler to implement, it's less secure than the authorization code flow and should be used carefully, especially with sensitive data. The resource owner password credentials grant allows users to provide their username and password directly to the client application, which then exchanges them for an access token. This flow is typically used for trusted applications, such as official mobile apps, but should be avoided for third-party applications due to security concerns. It bypasses the user consent step, which can expose credentials unnecessarily. The client credentials grant is used for machine-to-machine communication, where no user is involved. The client application authenticates itself using its client ID and secret, and receives an access token to access protected resources. This flow is ideal for backend services that need to communicate with APIs on their own behalf, rather than on behalf of a user. Compared to other OAuth libraries, Apache Oltu stands out as a Java-native solution that supports both OAuth 1A and 2. Its modular design allows developers to pick and choose components based on their needs, making it flexible and efficient. Additionally, it benefits from strong community support and extensive documentation, making it easier to learn and implement. One of the most common real-world use cases for OAuth is social login, where users can log into a website or app using their Google, Facebook, or other social media accounts. Apache Oltu can be used to implement this functionality by handling the OAuth flow, obtaining an access token, and using it to make API calls to retrieve user information. This approach is both secure and user-friendly, reducing the friction of creating new accounts. OAuth is also widely used for API access control, allowing third-party developers to access your APIs securely. By issuing access tokens with limited scope and expiration times, you can control what data and actions third-party apps can perform. Tokens can also be revoked at any time, giving you full control over access permissions. Single sign-on, SSO, systems use OAuth to allow users to log in once and access multiple services without re-authenticating. A centralized authentication server issues OAuth tokens that are shared across different applications, streamlining the login process and improving the overall user experience. This is especially useful in enterprise environments where users interact with many internal tools. Mobile apps often use OAuth to authenticate with backend services. Access tokens are stored securely on the device and used to make API requests. Refresh tokens can be used to extend the session life without requiring the user to log in again. This creates a seamless experience for users while maintaining security. Debugging OAuth issues can be challenging, but there are common pitfalls to watch for. Always double-check that your redirect URIs match exactly what's registered with the authorization server. Verify that your client credentials are correct and have the right permissions. Inspect token expiration times and ensure tokens are being refreshed properly. Finally, use detailed logging to track errors and identify where issues may be occurring. Testing OAuth applications requires a comprehensive approach. Use mock authorization servers to simulate different scenarios without relying on real providers. Test all supported grant types to ensure compatibility. Simulate token expiration and revocation to verify that your app handles these cases gracefully. Finally, validate error handling to ensure your application can recover from common OAuth errors. In a microservices architecture, OAuth plays a crucial role in enabling secure communication between services. Tokens provide fine-grained access control, allowing services to interact only with the resources they need. Centralized authentication reduces duplication and simplifies management. This results in a scalable and maintainable architecture that can grow with your application. In enterprise environments, OAuth is used to implement secure single sign-on systems, enable API access for business partners, and support compliance with industry security standards. Centralized audit and monitoring capabilities allow organizations to track access and detect potential security issues. This makes OAuth an essential tool for maintaining security in large-scale systems. There are several common pitfalls when implementing OAuth that can compromise security. Storing tokens insecurely, such as in plain text or unencrypted storage, is a major risk. Always validate token scope to ensure access is limited to what's necessary. Ignoring token expiration can lead to unauthorized access if tokens are not refreshed or revoked. And using weak client secrets makes it easier for attackers to impersonate your application. OAuth continues to evolve with new standards and security enhancements. Emerging technologies like DPoP, demonstrating proof of possession, aim to further improve security. While Apache Oltu remains a solid choice for Java developers, it's important to stay updated with new developments and consider integration with modern frameworks that may offer additional features or better support for newer standards. To deepen your understanding of Apache Oltu and OAuth, there are many excellent resources available. Start with the official Apache Oltu documentation, which provides detailed guides and API references. The OAuth 2 RFC specifications offer in-depth technical details. Online courses and tutorials can provide hands-on learning experiences, while community forums and GitHub issues are great places to ask questions and learn from others. To solidify your understanding, try building hands-on projects using Apache Oltu. You could create a social login system that allows users to log in with Google or Facebook. Build an OAuth-protected API that requires tokens for access. Implement single sign-on for multiple applications. Or develop a token management dashboard that lets administrators monitor and revoke tokens. Let's quickly recap the key concepts we've covered. OAuth is a standard for secure authorization that allows third-party applications to access user data without exposing passwords. Apache Oltu simplifies the implementation of OAuth by providing pre-built components for both clients and servers. It supports both OAuth 1A and 2, making it versatile for different use cases. And as a Java native library, it's ideal for developers working in Java-based environments. Now that you have a foundational understanding of Apache Oltu and OAuth, it's time to take the next steps. Experiment with different OAuth grant types to see which ones work best for your use cases. Integrate with real identity providers like Google or GitHub to gain practical experience. Explore advanced security features such as token binding or DPoP. And consider contributing to open-source projects to deepen your knowledge and give back to the community. The Apache Oltu community is active and supportive, offering a wealth of resources for developers. The official GitHub repository includes code examples and documentation to help you get started. Stack Overflow is a great place to ask questions and troubleshoot issues. And mailing lists and forums provide opportunities to connect with other developers and stay updated on the latest developments. In conclusion, OAuth is an essential tool for building secure, modern web applications. Apache Oltu makes it accessible and manageable for Java developers. Always prioritize security by following best practices and staying informed about new developments. And remember, continuous learning is key to mastering OAuth and staying ahead in the ever-evolving world of web security. If you found this tutorial helpful, please give it a like and subscribe for more content like this. Don't forget to comment with any questions or topics you'd like us to cover next. Sharing this video with fellow developers helps us grow the community and spread knowledge. Thanks for watching and happy coding. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.